And we'll begin the formal part of the event with acknowledgement on the country. I would like to acknowledge the Gadigal people of the Eora Nation, the Boronegal people of the Dura Nation, the Bardegal people and the Gamigal people upon those ancestral land on which we meet today. I would also like to acknowledge the traditional custodian of the land for the people joining us online today. And we pay our respects to the elders, both past and present, acknowledging them as the traditional custodian of knowledge for these lands. I'll also extend that respect to Aboriginal and Torres Strait Islander people here today. And for those that couldn't make it to the J.B. Douglas Award earlier today, we have 6 wonderful talks. We have Quan from University of Wollongong and also May from UNSW that actually share the top prize today. So that's the little spoiler. Well, in case you missed it, then that's the big news. So a big congratulations to both the winners and also the rest of the speakers that all gave wonderful presentations. Before we go any further, I'd also like to acknowledge the sponsors that makes this event possible. We have the SSA Central Branch, the ABS, the ASMs for sponsoring the event, also the winner prize earlier today. We also acknowledge and thank the sponsor, well, the generosity from Department of Medicine staff from Macquarie, Narasara from University of Wollongong, our business school from UCIT, and also School of Medicine staff from UNSW. And long may that sponsorship continue. And also is supposed to do a plug for the society that the society doing a wonderful mentoring program that is a very successful one this year, and they're going to restart that in 2022. And it's going to be open to all members of the society, and the program will connect early and mid-career statisticians with experienced mentor to provide them with career guidance and share the experience to help them achieve their professional goals. We're particularly looking for mentor at the moment, I think. And I've been given words and explicit instructions that being a mentor is going to be very rewarding and doesn't take that much of your time. So if you're in that sort of level of your career, please consider signing up because I'm pretty sure that there are a lot of people that can take advantage of experience and guidance. And if you're interested, you can, well, I will say that's aside from one of the jokes earlier, is if you're in that level, it's compulsory to at least scan that QR code to go in the web page and have a look. And if you're interested, please register your interest by Sunday, 12 in January. My computer is lagging for some reason. And finally, I'd like to acknowledge all the hard work that the council done this year. And also bring this up because we're looking for a new councillor for next years. It's starting from 2022 to 2023. And if you'd like to basically can have some time that you can warranty to us, we appreciate it. And so I can say that's a very rewarding experience, and you can actually do a lot of good to the professions. So if you're interested, please get in touch. And of course, that next year, Kara will be the incoming president. And we both looking forward to working with you if you'd like to join. I'm not sure I can full screen for this, so I think this is. Let's see. I can make this go away, and then I maybe make the dock disappear. Where's the? It's hard to talk. A bit more space.
Okay.
Okay, so I think this is the best we can do. All right, it's my absolute honor to introduce tonight's speakers, Professor Simon Jackman, CEO of the United States Studies Center of the University of Sydney. Simon graduated with first-class honors in government from the University of Queensland and earned his doctorate at University of Rochester and Princeton University. Professor Jackman's research has appeared over the last 30 years in the leading journals of political science. He served as one of the principal investigators of the American National Election Studies, the world's longest running and most authoritative survey of political behavior and attitude. He also served as an expert witness helping to secure verdicts against partisan gerrymandering in the United States. Tonight, Simon will give a talk in Statistics in the Public Eye, the case of predicting election outcomes. And please join me and give me a warm welcome to Professor Jackman.
Thank you. Or should I use that too?
No, that should be
okay.
Enough.
Oh, good.
And there's a
if I need to.
Here, if you,
okay.
Yep, it works.
Groovy.
There you go.
Thank you. I wonder if does that get bigger if what happens if I do? Okay. Hey, thank you so much for the opportunity to come and speak tonight. People sort of still hanging around for a lecture at 6 p.m. Very good. I'm between you and a drink, so we'll keep this pretty brief. Before I ran something called the United States Study Center, I had a long career at Stanford University in the United States, where I was a political scientist, but had a home also down in the statistics department there, and that was an incredibly wonderful phase of my career. And so quantitative methods, as we call it in political science, has long been part of what I do. It's a little unusual in Australia. Political science is not especially strong in the use of data and statistical methods. That is slowly changing in Australia, but really in the United States, it's actually kind of normal. It's the norm, and that there's a lot of crosstalk between social science disciplines, political science and sociology, economics, and statistics. And indeed, in some ways, I think the sort of my generation and people younger than me represent a little bit of a change in American political science, where and the social sciences, where I think for a long time, getting a quantitative training, being a good empirical researcher meant taking econometric classes, learning from economists, and I think we just sort of skipped one step in the food chain and go hang out with statisticians and data scientists directly, and that was a big part of what I did with students, postgraduate students, typically at Stanford, in my own work. And this talk draws on that fantastic environment I was in, where there was a lot of very smart people to talk to when you're sort of thinking through a modeling challenge. And so let me get into it, because we got a little famous out of this too, the people that and not necessarily always for good reasons. Okay, so in 2012, it was like the Moneyball moment for the use of data to predict an election outcome. There was all this op-ed stuff that Romney was actually doing better against Obama than anybody realized, and it's just that there was a number of us who were using actually just public polls, not private polls commissioned by the parties, but publicly, media polls essentially, and applying some statistical modeling that I'd been working on these techniques since about 2000, but they were really quite mature by 2012, and had a small consulting gig with Huffington Post, and to great hurrah, we called the election correctly in all 50 states plus the District of Columbia. You don't get a prize for guessing the election outcome in the District of Columbia, but a win is a win. But anyway, and that was a nice moment. And then by the 2016 election, I was back here in Australia, and good timing, because polls didn't do so well in 2016. polls, you might remember that election. Polls didn't do so well in 2020. And then also in Australia, you might remember the 2019 election in Australia, where I remember quite vividly going off to election parties that night and thinking, oh, probably going to have a change of government. And no, we didn't. And that's the case study that I'll present in a moment. I'll apply these methods to a case that's quite vivid for an Australian-based audience, the 2019 example. But this methodology, this machinery that we've got now is deployed and deployable pretty readily. It doesn't live in an R package per se. I should take care of that. And I noticed a few stickers here that I haven't got, but I'll make sure I was Googling them but yeah. But anyway, let's get into it. This so-called methodology is so-called poll averaging. I'll set up the model. There's a key ingredient in the model, so-called house effects, and those are biases specific to individual polling companies. I'll show you how we recover those. A few ways you can extend the basic model that are kind of interesting and get really challenging computationally, actually. And how, you know, is the model working well? How do we know? The answer is you don't usually until after the election. Okay, but here's a starting point. Public opinion polls, it's like radar in 1941. It kind of works, but boy, it's clunky and noisy, right? And so what is a public opinion poll? It's like having a noisy sensor, right? And the noise classically is what we call in statistics 101 sampling error, right? But there's this other nasty thing called bias that accompanies as well. So it's like not only is there noise, unreliability in the sensor, but there's also a validity issue that even on average, you're getting the wrong answer, right? So it's like, you're saying the target's there, but really it's there because there's just the device isn't calibrated correctly. The other thing, it's got quite limited resolution. It's like a radar or a sensor that says, well, we think it's in this box, right? And polls, at least the published polls that we work with, and when you're working with public domain polls, you see in the Australian newspaper, 43. And you know, they've rounded that, right? So what they saw in-house was somewhere between 42.5 and 40. So now that's not, that rounding error is small relative to sampling error, but the sample sizes they're using, but nonetheless remains another source, source of, if you will, error. And then most critically, the snapshots, right? It's not continuous time monitoring. It's like the radar is slowly and it comes back around and hits your target again. In the case of Newspoll, the poll run by the Australian, that's in the field every fortnight. And then it steps up to weekly during election campaigns. And then even then, they're really only in the field from typically a Thursday night through to a Sunday lunchtime, right? And then they go dark, and then you get the results in the Monday or the Tuesday edition of the paper. So you've got this periodization, and you know, in the US where you've got a lot small polls, and you can actually start to make sense to start. I've had students play with continuous time versions of the model, but you know, what we'll do is discretize time when we work with this. Oh, and this is the other issue, and this is a problem for the radar application too. Depending on the target, right? Is it on a ballistic trajectory? Now, if it's on a ballistic trajectory, that's great, right? When you're tracking. But if it can maneuver, that's an issue as well. Particularly if it's taking a while for that next radar sweep to come around. Right? What's the thing done? If you know, if it's got a law of motion that you think you understand well, then that's not so bad. But public opinion, voter sentiment over the course of a campaign well, we don't know. We don't have a lot of theory about that. We know politicians are desperately trying to move the needle, right? But they sort of cancel each other out a bit, and the changes are kind of small, frankly, relative to the resolution of any single poll, at least. And indeed, that's one of the original motivations for this whole methodology, is that the way I remember coming across this, being attracted to this idea, was sort of, you know, I'm a Bayesian by inclination. You sort of go, geez, these polls, have we got any prior information? And you go, well, kind of what the polls were saying yesterday would surely be a good guess as to, right? Oh, and we've got more than one poll too, right? I mean, you've got a poll and they've got a poll. And, you know, I think the Bayesian methodology, just sort of way of thinking, just set yourself up for like data and prior sort of, you know, at the end, it's all information and you're just trying to come up with a good posterior. Well, you'd like it to be centered in the right place. And Bayesians have an uneasy relationship with concepts like bias, but you'd like it to be centered in the right place. And you'd like, and you know, through, particularly if, you know, there's good large N arguments, frequentist arguments that suggest these things follow normal laws. And we know in the Bayesian case for normals and normals, you get normals that have smaller dispersion than any given information source. So all that was very attractive to me. I remember puzzling through this going, oh, okay, maybe there's something to do here. And that was, frankly, that was the original impetus, that 50 plus or minus 3, can we do better than that with your 50 and your 51 and your 49 and my, you know, and what the polls, oh, actually, no, we actually might be in a better place than we imagine. And then you go, oh, and except now we've got all the other stuff about the bias to deal with. Oh yeah, and then you've got perhaps multiple targets in the voting context. Well, I'm not just tracking Labor, but I've got these Greens, and then there's this Clive Palmer bloke, and you know, and we know they all have, but some people aren't going to vote, and you know, things like that. In the American case, you're not just tracking, and indeed even in the Australian case, but the American case is the one I know the best and have worked on the most. Election tracking there for a presidential election is really 50 targets flying in close formation, right? The 50 states, and we've got a lot of empirical evidence to draw on that we can start, you know, we can get a good prior sense of what the covariance of those trajectories are, but then you got this really big sort of state vector that you're tracking, and that's where the computation gets, you know, non-trivial. But the computation is actually pretty trivial for these days, at least, for the model I'll show you. And so here's the model. Let T index days, so that's our discretization of time, will be down to the campaign day. And what's the data we observe? Well, when you're working, again, not for a campaign, you're in the public domain, you're seeing polls as they appear, released by newspapers or sometimes by polling organizations. And what do they report? They don't give you the micro data, they just give you slap. 52, 48 on a sample size of 800, and we're in the field between Thursday and Sunday. End of story, right? So you get periodization, which we're gonna, and we just usually pick the midpoint of the field period. We get a proportion between 0 and 1, and we get a sample size, quote unquote, sample size, right? Because it's not, you know, and this is where any of you that have some sampling statistics under your belt know the difference between the nominal N and the effective N, N underscore EFF, after weighting and whatever the design was used in informing the data. Now, the survey companies seldom pull the curtain back and let you, you know, and if you speak to them and say, what's the effective N? They go, who the hell are you? Like, that's very scary to them. Oh, let me, we spoke to 1,200 people. Well, I know you spoke to, okay, you say you spoke to 1,200 people, but what was the design? You know, because I'm trying to put your, you know, numbers into our model. And so typically, you know, there's another whole version of this model where you actually try to work out, the polls aren't as precise as they say they are. That what's kind of the rough correction you ought to be using from the nominal n to the effective n, trying to back out the design effects associated with these polls. But that's not I'm going to focus on tonight. So to keep things simple, particularly in real time as the campaign is unfolding, the data is arriving literally day by day. We just work with the nominal n as reported by the survey company. We just use treat the variance as observed, and you can play with that a little bit, but to keep things simple, particularly in the talk tonight, just the version of the model where we just take the norm, again, baby statistics, P1 minus P over N as the, or in this notation, Y, 1 minus Y over N. Okay, so the observed stuff's in that cyan color. The unobserved stuff that we want to learn about will be in that orange color. And so, and it gets a Greek letter, xi. So the latent state is xi, all right? And here's what we get. In the election context, reality is revealed on election day. Right, it's like the missile launches on the last election. We knew where it was, and then it's on this trajectory, and then it lands again. We see it, right? We know it with certainty. It's an atom on day one and on day cap t. All right. So that's helpful. And indeed, if it weren't for that, the whole model kind of unravels. And then here's the model for the data, for the mean, right? And that is, it's reality plus bias, right? So xi of pole P is the state vector on the day that the pole was in the field. So T of P, just an indexing function, matching poles to time. And then who did the poll? Polling company J did that poll. And that's significant in a moment. I think that's on the next slide. I'll unpack that for us. But essentially, that's our model, truth plus bias, but both are unobserved, right? And so you can start to see some issues immediately. Theorem, any number can be written as the sum of any two numbers, right? So we've got an identification problem here straight away. Right? I observe one thing, but I say it's an additive function of two things. Well, right? You're going to have to nail something down. And so that's why the fact that we observe xi1 and xi actually gives us a little bit of anchoring, identifying information there, but that's not quite enough. Ooh, okay. So my bullet points there didn't render quite right. So, but I'll broke my markdown this afternoon, but that's all right. I'll just walk us through it, and helpfully each bullet point sort of begins with a bit of orange text there. So where do these biases specific to each house? And we say house, just that's a term of art. We don't mean the house in which a respondent to the survey lives in. We mean the survey house, the survey firm, the company doing it. And they're called survey houses. It's sort of an old term, but the sort of firm effects, if you will, they arise from the fact that different survey companies use different methodologies. So random digit dial, which is increasingly not done because it's too expensive, particularly in Australia. Increasingly you're seeing a mix of robo calls where it's voice activated, you're talking to a computer basically, or so-called web panels where people are recruited to sign up to take surveys, and then there's an awful lot of statistical adjustment done to sort of try and make those match populations of interest. There's variations in the weighting that's done. There's variations in survey mode. RDD uses live interviewers, while you've got the robopolls, or so-called IVR, and then you've also got web self-complete. There's a fair amount of evidence that suggests sometimes with vote, but typically more sensitive things than that. But vote can sometimes be a sensitive issue to say to someone that you're actually going to vote for Pauline Hanson or for Clive Palmer, that you might censor yourself. But typically it's around matters like reporting racial prejudice openly on a poll, that you actually are a prejudiced person, and a question, right, revealing things like that about yourself. That's much more easily done in a web self-complete mode than on a live interview. And also, we also see it in survey research using the endpoints of scales. Would you say you're very upset, it makes me very angry, or you're very, those endpoints in live interview, we're all just a little bit more moderate, right? We're going to give the 2, 3, or 4 answer, and the 1 and the 5 points of a 5-point scale just get used a tiny. So there are real effects to mode, so-called survey mode. And then there's more banal things like, how did you ask the question? Are the Greens in the question, or have they got a volunteer Palmer? Did you actually list Palmer as one of the options they could, right? And so all of that stuff, and all that stuff's happening all at once, right? It's kind of the sausage making. And we don't see that. We just see, wow, wait a minute, you say you're using random sampling, and you say you're using random sampling, and you got different numbers, and you go, okay, well, we have theory about that. Sampling error could generate, but there seems to be, a bit of over dispersion. And then we'll come back to that in a minute. If only there was over dispersion. If anything, it goes the other way. And we'll come back and talk about that a little later on in the talk as well. Right. Okay. So those are the sort of the theory from the public opinion and surveying, and also a lot of experience just with working with survey companies that I, over my career. I commission a lot of surveys, and I've overseen a lot of surveys. There's an awful lot, there's even in the survey literature something called total survey error, is this sort of framework to try and understand all the possible sources of bias that can accompany a survey, quite apart from the classical one we teach our students about in baby statistics, sampling error, all those other things that can go wrong with polling. Anyway. So they're there. And then we use, what is a fairly standard model, frankly, across, well, science. It's just that different disciplines call this model different things. Depending on where you are, it's a Kalman filter in economics or engineering. It's a state space model. It's a hidden Markov model. It goes by different names depending on what discipline you came up through and when you got your training, I think. But my generation of social scientists who do statistics kind of know it as a state space model, and so we've got this observed stuff, the poll results. And we've got this, right, this observation part of the model, measurement part of the model. Why? And we're going to just, use large N arguments about from, again, from baby start to say it follows a normal law. It's got that mean that I talked about being a function of 2 unknown quantities, and the variance that's just a function of Y and the sample size of the poll. And then we're going to have a model, a law of motion, if you will, and the one that seems to work pretty well is just a random walk, right? So a Gaussian random walk, but with the 2 endpoint constraints. Right. Yep. Right now, I need to point out immediately, right? You only get that second endpoint constraint after the election. So when you're doing this in real time, you've only got one constraint, where the trajectory started at the last election. The other thing is we don't know this innovation variance parameter, omega, this omega squared is also unknown. And so we seek, right, that the sequence, we want to get this sequence out. And when you're fitting it in real time, it's only up through, obviously up through the current day. And then because trivially forecasting with this model, it's locally constant, right? A random walk. So you kind of stop and that's kind of unsatisfactory. You know, you can obviously extend this to locally linear. Or there's even another version of the model where you've got prior information about where the election outcome is likely to be based on past election results, some sort of, you know, and that information is typically pretty vague, right? If I said to you right now, what do you think the ALP's share of the vote will be at an election 6 months from now? And this group of data people would sort of rummage around and probably come up with some stuff. But if we sort of put hand on heart, how much confidence do you have in that? You know, we're going to end up with sort of plus or minus pretty big, probably. Even just the empirical record would suggest that about the best you could do 6 months out might be plus or minus 3, plus or minus 4. Right. So to the extent you want to put a blob of prior information on the end state, it's not especially precise, but it actually it did work for some people quite well at least in the 2012 election in the States. We want to recover these house effects. They're great. Shame on you parameters. You get to throw back in the face of pollsters after the election. And by the way, pollsters hate this because unlike so much of what pollsters do, the thing about election polling is that there's going to be a real number, right? Unlike, what's the percentage of people that approve of the way that Scott Morrison is doing his job? Oh, it's 48. Well, is that right? How would we know? Is that, you know, you never get tested on that, right? Presidential approval, or the proportion of people that think climate change is happening. How would I know if I've got a biased number or not? Right? It's not like the census or there's some source of ground truth out there for that, right? But election polling, right? Oh, particularly in Australia, high vote, you don't get, oh, well, oh, the electorate, oh, it was very odd, and low voter turnout really confirmed. No, we've got compulsory voting. You know, 90% of the, you know, of the adult population, citizen population is going to vote, right? So the pollsters in Australia there's a lot of late change. The last 72 hours were just, we've never seen anything like it. The way, you know, so you get a lot of that as well in Australia. That's always the, a lot of people made up their mind late. Oh, okay. Just this time, or is that the truth? Oh no, just this time. Oh, okay. So we want to estimate the house effects. They're important. And also, now that innovation variance parameter, that's it. You know, at what pace is public opinion and voter sentiment evolving over the course of an election? Now, that's a tricky parameter. There's a lot of good theory to suggest that until the formal election is called, that's kind of close to zero, right? People aren't really paying that much attention. It's evolving really slow. Or the other model is, it's a jump model, right? You just get these shocks of information, right? It literally is zero, and you get these bang, you get these jumps, right? It's just that when you're in the election, maybe the jumps are happening every day. And again, there's not a lot of information with which to estimate this data. It's sort of a model where every day is a jump of, you know, a different sort of model for that, or every day is, the presumption is every day is constant. It's just that a small proportion of them are jump days. You know, we've played with that one as well. The model I'm about to show you for the Australian election, we hardwire a jump when Morrison knocks off Turnbull, right? There's like a bang on that day. And we did the same thing when, you know, when Turnbull takes Abbott and leadership changes. They're sort of the one moment we've got jumps that we hardwire into the model. But other than that, I think a little implausibly, we say that this thing is constant over the whole 3-year election to election period. If you like looking at models as directed acyclic graphs, then there's a stylized version of the model using the normal conventions that circles unobserved quantities and things in boxes are observed. And I guess we probably want a box around Xi1 as well. That's observed. But okay. Now, yes, the model is over parameterized. I talked about that earlier. You know, is it that all the poles were off by some amount, and you know, you could move either the Xi trajectory or the house effects delta any movement there will offset one another. And so, you know, we say we've got an identification issue or a lack of identification. Now, the endpoint constraints do solve that, but in real time, we don't have that. And so one thing, again, perhaps a little implausibly, there's a few things you can do. You can use the delta you observed from that pollster in the last election, which kind of assumes they haven't learned or updated, you know, and often the pollsters do, or sort of an assumption that sort of, you know, worked really well in the US in 2012, but has not worked well since, is this so-called sum to zero normalization, that collectively the polls are unbiased. So as I sum over the industry, right? So as you estimate these deltas, you sort of got this one rank one reduction constraint that you impose on the model. And again, you know, the way I estimate this is it's sort of a toy-sized problem. It's not especially, particularly when you're just tracking a single target. You know, it is literally 6 lines of scan, and imposing these constraints either as the model's running or ex post, and so-called post-processing the output from an MCMC algorithm is another way to impose these sorts of constraints and different sets of constraints as well. So imposing these sorts of restrictions is not especially tricky. And as I said, okay, so, oh yeah, in statistics, this a long time ago was called a DLM, a dynamic linear model. I haven't heard DLMs referred to in a long time. But again, I think it depends on your vintage and where you got your training. There's a lot of packages for Kalman filtering in R, but the house effects and the partially observed structure of the data, that makes it just a, you know, depending, some packages are fine with those sorts of augmentations, some aren't. So there's, you know, we've done all manner of different things with this. And again, this is a model I've been playing with now for 20 years. And you know, back in the late 90s, 00s, early 00s, when R and computers ran like treacle, you had real no option but to sort of code stuff up in C yourself. But then along came JAGs and RJAGs, and then you know, Stan, and now increasingly there are really quite some nice flexible packages for state space modeling, Nimble and POMP, are really quite open with sort of the things you can jam into the model, and are running off and doing either approximate Bayes or full-on MCMC under the hood, or sometimes wrapping Stan. So it's life gets considerably more tricky once you leave the scalar state, right, behind, and once you go up to a vector state, or then even kind of, if you will, then you got matrix state or a tensor state, if you will. Then you probably and again back in 2012, when I was modeling all 51 US jurisdictions in parallel, there was no real option but to write our own C and C++ for that. So let me do an example. And here's the Australian federal election. We had 226 polls fielded between the two elections, 16 and 19, in the public domain. We discretized time, so we've got 1,051 days. There's only 6 distinct polling companies in the US. You've got 50 or 60, you know. It's Australia, people say, there's so much polling in Australia, that's what's ruining Australian politics. Dude, if the problem is not enough, right? You want to just have so many, it's just all just, right? But, you know, the way the country sort of grinds to a halt waiting for every fortnightly news poll, it's a very unusual, very Australian sort of phenomenon. Polls in the US are just like, well, there's one every 5 seconds, what's the big deal? Whereas in Australia, they have this outsized sort of weight in the public conversation. We augment the model with the discontinuity when Morrison replaces Turnbull. And I just run this separately for the different scalar targets. And you can see that Essential, a Melbourne-based polling company, supplies the bulk of the polls. Ipsos, Roy Morgan is out there doing some face-to-face polls. And you've also got, as I said, News Poll, 61 polls. So that's sort of the provenance, if you will, of the data. So this is the raw data, and you can see the dispersion. And here's fitting the model. With the endpoints known, and you can see the overestimation here straight away, but the other thing is that's 3 years. If you actually go down to the this calendar year 2019, you know, the election was sort of in the middle of the year. You know, the data are really quite spotty, and you can see how, you know, that the assumption of a random walk, you know, and it's picking up this endpoint constraint, you know, being driven to this. And you can also see the effect of the endpoint constraint means that, you know, I remember showing this model once and someone went, well, that's really impressive, Simon. You fit a line that doesn't run through the middle of the data. And that's because the data are all, right, biased upwards. Something you don't know until after the fact. Right, but in the US, in that last 6 months, like that's just confetti, right? There's so much data. The Australian case it's kind of interesting, right? And for statisticians or modelers, right? Because it means what we're saying becomes increasingly sensitive to the assumptions encoded in the models. You can see this other phenomenon, the banding you get when you're tracking something like green. It's going to be one of 4 numbers. It's going to be 8, 9, 10, or 11. Occasionally a 12 or 13. Right. It doesn't get to go take on those range of integers between 35 and 45. It's going to take on the range of integers between 8 and 11 or 12. Right. So you see this banding in the data for the greens. And you can see, right, some polls, oh, the greens are on 14, really? That's enormous. Ipsos with the green vote that high, Morgan, and you can see, you know, The other thing that happens in the Australian case is the conversion of the first preference number into a two-party preferred number. I didn't talk about that, but different polling companies, there's more or less an industry standard for doing that, and that is you just look at preference flows at the last election and you map that onto your first preference numbers and then do integer rounding at the end. And the two lines here, one's got the endpoint. You can see, well, it went away when I moved the mouse. That's annoying. But there's one endpoint constraint, and came back. Yeah, great. I'll leave it like that. You can see the brighter line there is the one that with the endpoint constraint. The grayer line is the trajectory you get where you've only got the beginning constraint and you've imposed sum to zero over for the house effects over the campaign period. And so, you know, you would average the polls that were available, and you've got a 51-49 election when it was actually a 51-49 the other way, right? And that's the story of the last election in Australia, by the way. And when I say it's the story of the last election, I mean it's the story of the last election. Bill Shorten had the plane waiting to fly him to Canberra, right, from his election party in Essendon. They'd literally measured the drapes in the lodge, right? I think members of the cabinet had preemptively resigned and were not contesting the 2019 election, Julie Bishop and Christopher Pyne in particular, in anticipation of the coalition being likely to lose the next election. The polls, this is not just a talk for us, but the polls shaped the national narrative, and indeed decisions about what go on to powerfully shape the composition of the current government. That is, frankly, it was moderates that left, Bishop and Pyne, way more moderate than a lot of their cabinet colleagues who decided. Steve Chobo, another one that left ahead of the 2019 election. We get bounds, of course. This is fully, we get a, if you will, a day-by-day marginal posterior, and I've just sort of plotted the 95% bounds. You can see the jump associated with the Turnbull to Morrison transition. Labor got a boost out of that, but once we've even with the endpoints known, you can see this this recovery for the coalition, or this fall for Labor, that's actually pretty steep in a 6-month period, and we can reconcile this after the fact. This is sort of the post-election version of the model with the two endpoints observed. We can see sort of they're shedding vote share at the rate of about 0.5 percentage point a month from a high watermark right as the country goes to Christmas break in 18. But by the time of the election, they've sort of, Labor can't win government with a primary vote there. And it's a rare case of the opposition going backwards. Typically, as a big swing brings a government to power in Australia, and then over time that gets whittled back. And the 2019 election actually saw Labor's primary vote share go backwards. It's sort of a mirror image to no small extent for the coalition. We also recover those posterior densities over the rate of change parameters that, again, I think are kind of a little implausible. I actually don't think that's kind of the right model to assume that that's constant over the entire campaign period. But and these are the parameters of real interest, sort of how biased the industry was. They all underestimated, and again, you get to recover these after the fact. But under the model, if you assume the model, and again, perhaps the implausibility of the, you know, the law of motion and the fact that it's got a constant innovation parameter, but you get these significant, these are big biases, right? To be systematically underestimating coalition first preferences by, you know, the best of a bad bunch was News Poll with an average underestimation of first preference vote share for the coalition of about 3 points, YouGov 5 points, Essential about the same as News Poll there. The real story, YouGov just really messed up with respect to the other vote. You can see those Ipsos numbers for the Greens, some pretty big implausible. And remember, these are biases with respect to the target you're trying to hit's about 9, and you're off by about +3. That's you know, 3 on 9. You know, it's not trivial at all. And it was a really not a great election, and it was very interesting watching the pollsters trying to rationalize ex post how their errors could be as large as they are. When you look at two-party preferred, YouGov actually, their biases on the primary vote tended to offset, so they ended up in not a bad place on first-party preferred, on two-party preferred, but everybody else was off by a lot. And by the way, that's a lot of bias. If you think about the variation just empirically in Australian election outcomes, right? You know, we seldom have an election outside of greater than 53 for the winner on two-party preferred, right? So to be carrying around, you know, 2.5 to 3 points of bias on that number, like, wow. Like we had you thought this was going to be a 83 or 84 type, you know, like if you put it in those historical reference points, you had the election down here in the historical sort of distribution of election outcomes, and it's actually like, you know, it's another way to, you know, 50 ways to shame pollsters. It's method number 17. So did the polls herd? And the last time I gave a talk like this, I actually had a picture of sheep, and it was pointed out that sheep do not herd, sheep flock. So this time I've got cows, which herd. And the answer is probably. Pollsters will never tell you they do that. Oh, no, I don't look at my competition's numbers before no, they do, right? Because I've worked both sides of this. I've been a client, but I've also been in the engine room. And the number of degrees of freedom you have when it comes to things like weighting, which method should, oh, well, this one gives me 47 and these other methods give me 49, and which is the right, oh, what's so-and-so saying? Right, the temptation to herd here is immense. Why? For the reason I spoke about earlier, the commercial pressure. Right, this is a number where reality will be outed on day cap T. The truth will out, and that has commercial implications. And all those things I talked about earlier, all those choices you have. And you got this sort of period where the data science team or the data science nerd, typically in Australia, it's often just one, maybe 2 or 3 people at a market research company, YouGov or News Poll or whatever. And what set of numbers am I going with here? There's a real gulp moment. And of course, so it's better to be wrong with others than be wrong on your own. Ipsos, though, paid a real price. Their client was the Fairfax papers before they became 9. And you'll note that they cancelled that contract. They've got a different pollster now. One of the few times there's been a real accountability moment in Australian polling. Essential Media is not publishing vote intention at the moment, right? They've chickened out. right? Oh, there's so many and they don't want to get caught out again. Their media partner is The Guardian, that I think is sort of happy for that to be the case. But YouGov is providing, does a news poll now, and they're providing regular soundings of vote intention. But literally the 2019 cycle scared so many pollsters that they stopped producing numbers on something that actually is connected to reality. Polling on things that, right, on other things do that all day long, but polling on something where there's actually a validation moment coming, not so much. That strikes me as implausible. Once we get into the election, I just think it's implausible for a pollster like Essential not to be producing vote intention numbers, and so we'll see how we go over the summer and into the new year. Brian Schmidt understands what under dispersion is, and was out of the blocks very quickly with an op-ed. And this is a well-known phenomenon around the world, that there's this compression in data points you start to see as the election gets close, and that accountability moment comes close. I'll skip through this because we're running short on time, but we came up with a simulation-based test. And we just looked at theoretical dispersion to observed dispersion in the Australian polls, working backwards from the election, and how often do we see dispersion greater than that which we expect from sort of a classical, sampling story. And the answer is, here's our, the orange line is our simulated dispersion under, the conditions of simple random sampling. The white line is the observed dispersion. And you can see this collapse in dispersion for the coalition's numbers right up hard against election days. You go back in time. But at every point, though, it's we're actually over dispersed for the Greens. Thank you, Ipsos, for those 14 numbers. Ultimately costs you your contract with Nielsen, but good for you for being brave and not hurting. And you can also see the under dispersion is really striking. For a coalition two-party preferred, and hence trivially, because ALP two-party preferred is just 1 minus that. So the two-party preferred numbers definitely also have a lot of under dispersion in them. So there's some prima facie evidence for herding in the Australian case. Look, I won't say, I've alluded to extensions of the model. When you're actually tracking a target that's constrained to sum to 1, and we've used Dirichlet multinomial models for those. And then the candidates with drop in and drop out, they're complicated. Primary elections are a great case in point in the US. But again, in engineering, bogeys come, and then or there are new targets to track, and that's a pretty trivial problem in signal processing, and has been for a long time. And then the other one is the multiple jurisdiction problem, where the real hard part is, gee, what's that 50 by 50 covariance matrix? And getting your arms around that and computing, populating it and computing with it is sort of an interesting tactical challenge and substantive challenge as well. But look, I'll leave it at that. This has been sort of a really great little example in my career of where a model that is really well understood in so many other disciplines hadn't really been deployed in political science, and very quickly, because it's politics, you get all this attention very rapidly. and that's awfully giddy and fun. I think, look, with great power comes great responsibility and great risk. When you're right, it's great, and you get lauded as oh boy, these people knew what was going on the whole time. Wow. But for this, what people didn't, the model is just taking published polls and making a few assumptions. If the published polls are wrong, then the model's going to be wrong. There's no magic here, and that's a great lesson too. How to be, I think, for all of us as people that work with data and the people we're making advice to, how do we communicate those limits to people that really want to run perhaps a little harder than we might be comfortable with? We understand everything that went into the making of the number we're putting up. We get back to some, I think, perennial issues in where statistics leaves the statistician and goes into the hands of either the lay public or a policymaker who might be and sometimes motivated by things different to what we are. And this is a really sort of great example of that, and why I was happy to exit the field and sort of just do this more for academic audiences after 2012. That turned out to be awfully good timing on my part, but in many other contexts we don't have that choice. And COVID, I think, was perhaps a great example. But I'll leave it at that. And thanks for the opportunity to come and share this work with you. As I said earlier, Australian political science is not especially quantitative. I can't give this talk to many audiences in my home field here in Australia. So it's a delight to be able to come and talk to an audience where all the words I used you understand. So thank you for the opportunity, Thomas. Thank you.
I think we have maybe a few minutes for questions and comments. Matt?
So you spoke a lot about polling companies. Do you have anything to say about betting companies?
Yeah. So literally this afternoon, I was knocking the slides together. I thought about dropping in some of my work on that. So I've done, so I got into a little bit of a back and forth with two economists, one of whom is now a member of Parliament, Andrew Lee, and Justin Wolfers. But they have a paper saying, forget the polls, follow the money in the betting markets. They're more reliable than the polls. And I went, there's just not enough insider trading for that to be possible in Australia. And so I've got a paper from the 2016 cycle. I sort of did this debunking exercise where I was scraping betting market websites literally hour by hour for about the year leading up to the 2016 election. And what do you see? When news poll drops, the markets move. It's not as though people out there in the playing on betting markets with politics have some deep insight. They're reacting to the polls. And there are 18 different ways of demonstrating that. So there's no magic being captured by the betting markets that isn't being captured by the polls. And indeed, the betting markets were catastrophically wrong on the headline, who will form government number in 2019. You might remember, it's forgotten now, I think it was Sportsbet paid out, I think 3 days before the election on the Labor win. It was that certain to them. The other one is the marginal seat markets. Well, actually, there's a market on all 150, right? They essentially come to someone like me. I don't know who they go to, but they go to a political science. I don't know who it is, but literally they just read off the pendulum. And you can plot, if you plot their starting prices when they put those markets up live, it's really the last election, maybe a little bit of a fudge for if an incumbent is retiring. They've got a very basic model that's essentially, and those markets tend to be mom and pop markets. You know, I've had students run little experiments there. With $100 bet, you'll move the price. It's very thin volumes in those seats, and they don't have great predictive performance either about what's going to happen seat by seat in Australia. So that's my take on the value, if you will, of the information. At least, if the problem is you're trying to predict the outcome, there's no extra information from the betting markets, typically, at least the last 2 cycles in Australia, than what's in the polls. Hope that, good to see you again.
Yeah, so a nice talk, thanks. I had a question about house effects. So you pretty much, when you're predicting the next election, all you've got to go on is the last election to estimate the house effect, right? And I can't remember the word for it, but people are sort of, one explanation I've heard for house effects is that people are kind of ashamed to vote Conservative.
What?
Kind of ashamed to vote Conservative, sort of a bit guilty about it. And if a government changes to become more right-wing, or I guess less right-wing, that effect could become more of a thing. So I guess with changes in direction of government, and like Trump 2016 and Morrison 2019, there's a big move to the right. Like, I guess there's nothing you can do about that except guesswork. I guess if you want to try and deal with changes in leadership and the influence that has on house effect.
That's fascinating. I hadn't, look, in postmortems on US election polling, it hasn't been done in Australia, but it's a really good idea to understand the 2019 case. But in the US, right, the so-called shy Trump voter, there's actually not a lot of evidence to suggest they're shy. In the US, the issue, right, the word, right, I didn't mean that to be as funny as it is, but in the US, the really hard thing about US is non-voluntary turnout. And the cycle that I got my laurels for, 2012, was actually a really easy cycle. Obama is running for re-election. It's a rerun of 8 to some extent. And indeed, everybody doing public opinion work, be it inside the parties or for media organizations, what they learned also, big data started becoming the picture. You could actually see in many cases, depending on how you did your polling, you could see the voting history of the person. If they gave you some personal identifying information, you could look up on public records if they'd actually voted in the 2008 election. And so you weren't, the polling industry learned, don't rely on the self-report. Yes, I'm definitely going to vote. Actually, try and get some PII, which increasingly they were getting through the use of web panels, so you knew who these people were. And then look up on the voter file to see if they'd voted in 2008 and cue off that. If they'd voted in 2008, they're probably going to vote in 2012. People overlearned that lesson because 2016 was a very different context. And what Trump did was bring people off the couches of the Midwest, and everybody's sort of using, no, well, this person says they're going to vote, but we've never seen them before. And they voted for Reagan was the last time, or Bush or something was the last time we saw them, right? And Trump turned those out and blew up all the models, right? Now, Australia, you don't have that. So what it does do is throw the focus back on, I think you've got that's a really interesting, people are actually intended to vote for Morrison all along, but weren't telling pollsters for some reason. Look, and again, because the industry is so small and quite thin here, that particular hypothesis hasn't been very well, the commission from the, the Polling Council of America, you know, they throw really significant resources at some post-mortem work, even going back into the field and running some experiments on different ways of asking questions. What could be going on here? We really haven't done that same level of post-mortem.